Yeah, in this class we are going to discuss Vieta method. This is one of the method to find out a real root of the given polynomial. It's not for a transcendental equation. Whenever the given equation is a polynomial with real quotients, if we want to find out one of the real root, then we have to go for Vieta method to find out the real root. And also the another way is if you want to extract linear factor from the given polynomial, there we are going to use a Birge method. Birge method is one of the method to extract linear factor from the given polynomial, or we have to find out one of the real root only for polynomial with real quotients. This is an advantage and also disadvantage. Now, the Birge method is nothing but just we are using synthetic division method. After synthetic division method, we are using Newton-Raphson method. We are finding a next approximation value. Once we get next approximation value, again we go for synthetic division method. Continue this process until we get minimum error in the root. Yeah. Yeah, before I'm going to explain Birge method, keep in mind whenever I want to extract a linear factor from the polynomial with real quotients, there we are going to use Birge method. The very first step for Birge method is consider the given polynomial, say P is already written on the board. The steps I'm going to explain based on that. First, you have to what polynomial they're going to give. We are take it as P of x. The first step. In the second step, arrange the quotient of a given polynomial equation in decreasing order. Means we are suppose polynomial degree 3 means you write first term is a degree 3, second term is 2, x, a constant like that. You write it polynomial in the decreasing order. Okay. Next, perform the third step. Perform the synthetic division method with initial value p naught. Okay. Arrange the question. See, we have to frame a synthetic division table. Before going to write the synthetic division table, first you have to write the polynomial in terms of the decreasing order. And then you write the quotient. Highest degree quotient is A naught. The next highest degree quotient is A1 like that. Here we consider polynomial degree n. Therefore, synthetic process is nothing but first you write the quotients from the decreasing order. Suppose any quotient having a negative sign, write the negative sign along with that quotient value. And then the very first step is a first quotient of A naught, highest degree quotient of A naught is A naught only. Yeah, while you first step of synthetic division we are applying, then we get a new constant, okay. The first is A naught is A naught, that is we are going to take the new quotient is B naught. Multiply B naught with this initial approximation value, we get P naught A naught. Add these two, we get a new quotient is B1. Again multiply B1 with P naught like that. Continue until reach the last one. From that we get new quotient say B0, B1, B2, B3, etc. Bn. And then not only it's not sufficient for B0, B1, B2, etc. Bn, I have to find out C0, C2, etc. Again I have to do the once again the synthetic division method. Now from B0 then we get a new value. What we did for we get B0, B1, B2, B3, same thing we are going to do. We get a new constant C0, C1, C2, etc. Cn minus. We don't want Cn. Suppose you stop Bn here. Degree of polynomial B degree n means you stop Bn, but we have to stop C is Cn minus 1. Now once we get C0, say C1, C2, etc. Cn minus 1, in the next step, find the next approximation root by using iteration formula pk plus 1 is equal to pk minus bn divided by cn minus 1 for k is equal to 0, 1, 2, 3, etc. First iteration, second iteration. Repeat these steps 3 and 4. This is my new approximation value. Repeat the step 3 and 4 until p having minimum error. Then once you get minimum error p, then we have to take this is a one of the root of the given polynomial. This is one of the things. See, the another point we have to observe in the Birge method, Suppose they're given a polynomial, they're not given an initial approximation. See, if you want to go for this Vieta method, you must be required one initial approximation. Suppose they're not providing initial approximation, first you take the given polynomial, find out the interval. How to find out the interval based bisection method in bisection method? No, similar way I had to find out. I had to choose two values. Both the values are given as opposite sign. Make it as interval. Take the mid value. That is my initial approximation. While doing that way, then we can't expecting everyone extracting same linear factor. We can't expecting same root because someone may be taking the interval 1 and 2, you may be taking 2 and 3. 1 and 2 also we get opposite sign, 4 and 5 also we get opposite sign. Therefore, here they have a flexibility. Okay. Now, suppose they're not mentioned, usually they're going to mention the initial approximation because you want to overcome this ambiguity. Suppose they're not mentioned, first you identify two values, both the values give rise the corresponding polynomials must be opposite sign. Take mid value, that is our approximate what about initial approximation. For each iteration, we have to apply twice synthetic division method to find out B's B0, B1, B2, etc. Bn value, and also find out C0, C1, etc. Cn minus 1 value. Once we apply twice at a time a synthetic division method, and then using this formula, pk plus 1 is equal to pk minus bn divided by cn minus 1. Then you start from first iteration, second iteration, repeat this step 3 and 4 until reach P is having minimum error. Sometimes we get error is 0, but sometimes as possible as nearest to 0 error, I have to repeat this step. Then once we get that, that is our linear extra factor of the given polynomial, or that's one of the root of the given polynomial with real quotients. Keep in mind, Birge-Vieta method is only to extract linear factor or only finding uh, one of the root of the given polynomial. If you want to find out the rest of the polynomial, first you extract the linear factor, we get the remaining polynomial. Again, you repeat this process until we get all the roots. But it's very tedious if you want to find out all the roots. But at a time, it's possible to extract only a linear factor. Okay. Now, even though still have some ambiguity, I'm going to solve one problem on the board. Then I think become we get more clarity after the problem. Yeah, I'm going to write one problem on the board. Use synthetic division method, division, and perform two iterations of the Birge-Vieta method to find smallest positive root of the polynomial is 3 of x. They given polynomial degree 3, 2x cube minus 5x plus 1 equal to 0. Use the initial approximation P0 equal to 0.5. Also obtain the deflected polynomial. Yeah, Birge-Vieta method only extract linear factor. Okay. Yeah. Solution. Yeah. Now, anyway, they given already polynomial in terms of this is a given. Okay, what are the things they given? First, you write down. Given P3 of x equal to 2x cube minus 5x plus 1 equal, equal to 0. You neglect that. And then I have to take what is the initial approximation value they given 0.5. There is no ambiguity because they are already given what's the value of P naught. Okay. Now first you have to start first iteration. They given very clearly perform two iterations. Therefore I'm going to start first iteration. Okay, first iteration. Yes. In the first iteration, we have to apply once synthetic division method is already you know that. Okay, fine. Find out A naught, B1, B2, B naught, B1, B2, etc. and C1, C naught, C1, C2, C3, etc. Okay, fine. Now, first you arrange the given polynomial in a decreasing order. Yeah, cubic polynomial. Yeah, is already in the decreasing order. Therefore, what's the quotient of x cube is 2. X square is absent. Therefore, any term is missing, you write it 0. Corresponding quotient is 0. Next quotient of x is minus 5. Quotient of constant is actually 1. Suppose any quotient having negative sign, you write it negative sign also. What's the initial approximation value given? 0.5. Then first value 2 is nothing but B naught only. 2 into 0.5 is 1. Is 1. Add 0 plus 1 is 1. 1 into 0.5 is 0.5. Okay. And next you sub 0.5 minus 4 minus 5 is minus 4.5. Minus 4.5 into 0.5 is what actually minus 2.25. Add these two, what we get actually minus 1.25. Now these are the nothing but the values of, this is nothing but B naught, this is nothing but B1, this is nothing but B2, this is nothing but B3 because it's a polynomial degree 3, therefore we are expecting up to B3. Next, we want to find out next one, what actually another synthetic division method. At apply same synthetic division method once again, we get C naught, C1, C2, etc. 2 2 into zero point 0.5 is 1. We get 2. 2 into zero point 0.5 is actually, observe carefully, 2 into zero point 0.5 again we get 1. We get minus 3.5. See, I told very clearly while explaining synthetic division step, once you find out B3, C's values to find out C2. Suppose you find out B4, up to B4 I have to find out B's values, you find out up to C3. This is C0, this is C2, C1, sorry, this is C3, C2. Here stop B3, final, we get because polynomial degree 3 is B3, therefore I have to find out previous of the B3 value is C2. I don't want C3, okay. Now we have to take a formula for the step 4. What's the formula you have? The formula is nothing but pk plus 1. We know that pk is nothing but pk plus 1 is nothing but pk, yeah, pk small pk minus of whatever that b n divided by c n minus 1. Okay, yeah, it's just few minutes before I explain. No, same formula we are going to write. Yeah, yeah, minus 1 for k is equal to 0, 1, 2, etc. Now here I have to put k is equal to 0. That implies we get a first iteration value. P1 equals P naught minus n. Here n is what? Order of the polynomial. What's the order of the polynomial? Is 3. N is equal to 3. B3 divided by C2. What is my P naught? They given 0.5 minus of B3. What is my B3 value? My minus 1.25 divided by C2. What is my C2 is minus 3.5. Now minus into minus plus, plus into minus is minus. Simplify that, we get approximately 0.142857. I taken 6 decimal value. Whenever I to carry more number of decimal value, then we get more accurate in the root. 1.42857. Yeah, this is nothing but actually what actually after the first iteration, this is my P1. They are asking to perform how many iterations? 2 iterations. Therefore, again we are going to apply one second iteration. Second iteration. Yeah. Second iteration, we are going to write a table now here. Okay, fine. Yes. Now I have to substitute the values for what about the what is the quotient? The original polynomial equation quotient is 2. Yeah, 0, -5 and 1. But instead of P0, we are going to take updated approximation value 142,857. Okay. Yeah. Now we have to take once again for this values 2 only. 2 into 0.142857, you multiply that, we get 0.285.21. Just a minute. Yeah. Point 2 85714. And to add these two, what we get same value 0.285714. Again multiplied with 0.142857, we get 0.040816. Add with -5, we get minus 4.959184. Multiplied with again 0.142857, that is nothing but minus 0.708454. Okay. Add these two, we get 0.291546. These are the values of, these are the values of B0, B1, B2, B3. Okay. Next, move to the next one. Again, I have to do the synthetic division method. We are finding C0, C1, C2, C1, C0, C1, C2. 5, 7. Add this, we get 2. Okay. 2 into 0.14287, we get 0.285714. Add these two, we get 0.571428. Using calculator and do it. Again multiplied with this value, we get 0.081632. Add these two, we get minus 4.87755. Okay, these are the nothing but the values of C0, C1, C2. Okay. Next, I have to find out the next iteration value. Yeah, next iteration formula is nothing but put per k is equal to 1. In pk plus 1, what we get? P2 is nothing but P1 minus Bn divided by B. Yeah, Bn, what is my n value? That n value is fixed in every case. Yeah, what is n value is 3. Therefore, B3 n minus 1, Bn by Bn minus 1 means C2. Yeah, for the second iteration value 0.1485 42857 minus of B3 0.291546 divided by C2 minus 4.87755. Okay. Now we have to simplify for this. Simplify for this. Now we get P2 by using calculator 0.202630. After the second iteration, this is a value, one of the root of the given cubic polynomial. After the which one? Second iteration. Yeah. They're not asking to do it until we get minimum error. They given very clearly what about that we have to perform two iteration. After that perform two iteration, then we have to also obtain the deflected polynomial. This is a value. This is a is a root after the second iteration. It's the root of the given polynomial after the second iteration. After the second iterations. Okay, after the second iteration. Okay, fine. But not only I have to after the second iteration, I'm not telling this is accurate value because means they have a because we did only a two iteration. After the second iteration, what's one of the approximate root of the given polynomial is 0.202630. And also they are asking to find out deflected polynomial. Then how to find out deflected polynomial? Deflected polynomial is very uh, easy to find out the deflected polynomial here. Again, I have to write the given quotient of the given polynomial 2, 0, minus 5 and minus 1. Okay, 5. Now what? I have to find out deflected polynomial based on the approximate value of after the second iteration. Okay, 0.202630. Yeah, first you multiply, we get 2 into 0.202630 is nothing but 0.405260 add 0.405260 multiplied with 0.202630. What we get actually 0.082118. Add these two, we get minus 4.917882. Again multiplied with this approximated root of V2, what we get minus 0.996510. Add these two. This is not minus 1 actually, this is plus 1. Okay, we get 0.003490. The given from the given polynomial, this is not minus 1 plus 1. Now based on that, this much error we are expecting. Now see, observe. Actually, once you do the synthetic division, suppose the root is exact root, this value are expecting 0. But here is not equal to 0. Means this much error still have. Suppose apply another one or two iteration, definitely this value becomes 0. After the another two iterations, maybe third or fourth iteration. Whenever we get once you apply once in synthetic division method, the last value 0, then we say that corresponding root is exact root of the given polynomial. But still this is not equal to 0. Therefore, we are finding a deflected polynomial after the second iteration. Therefore, this much error you have. Okay. Since next, we are going to write the next step. Since B3 is nothing but P3 of P2. After the second iteration, how much error we get? In B3, what value we get B3, that much error you have still. Suppose we get B3 0, Then we say that what you have root is nothing but exact root of the given polynomial. 0.00349. This gives the error in satisfying the given equation. What's the given equation? P3 of x is equal to 0. Yeah, the deflected polynomial. Yeah, after the second iteration, this much error still have, because once you did a synthetic division method, this is not 0. What we get the value b3, because it's polynomial degree 3. Suppose polynomial degree 4, what value we get b4 after the division, synthetic division for the root, that much error you have. Suppose we get 0, that is exact root. The deflected polynomial after two iterations given by given by yeah b naught x square plus b1 x plus b2. Don't write b3. What is b naught? 2x square. b1 is 0.405260 into x. b2 is minus sign. Yeah, okay. This is b naught. This is b1. This is b2. Yeah, once you extract linear factor, in the cubic polynomial, you extract linear factor. What's the remaining factor is polynomial degree 2. Therefore, x square x, the constant minus 4.91788. Yeah, this way I had to find out deflected polynomial. This is approximate root of the second iteration. The corresponding deflected polynomial is, once you extract linear factor from the cubic polynomial, what's the remaining? It's a quadratic form. Now this way I had to find out linear factor and also deflected polynomial from the which method? Vieta method. Now before I'm going to wind up this video, I'm going to explain within 2 minutes what are the important steps that to follow to solve Vieta method. If we want to solve, here I record one initial approximation. Suppose they are not given, how to find out? First you find out two values, both the sign values must be opposite sign. Then you make a bracket, take mid value, that is my initial approximation. But here they given already, they saying that try to find out smallest positive root. Therefore, first you have to arrange the given polynomial in the decreasing order. After that, you write the highest degree polynomial, highest degree coefficient is first, and then second, highest, third highest, like that. X cube, x square, x and constant. Any quotient, any term is missing means the corresponding quotient we are going to write 0. And then you take what's the value they given 0.5 and then 2. 2 into just like a synthetic 0.5, you substitute until reach B3. Again from B0, B1, B2, B3, find out C0, C1, C2 using same 0.5. Okay, once we get that, now we are using another one formula, pk plus 1 is equal to pk minus bn divided by cn minus 1, where n is a order of the polynomial. What's the order of the polynomial here? 3. Then we get, put k is 0, we get a first iteration value. Using the first iteration value, again repeat that synthetic division method to find out b's and c's. Once you get k is equal to 1, find out p2 value. This is complete the second iteration. But in the problem they given, perform 2 iterations. Therefore, this is the root of the given polynomial after the second iteration. Now, I want to find out deflected polynomial. Therefore, again I to apply the synthetic division method based on this root. Suppose we get B30, then we say that what I written this root is the exact root, but still have a error. This much error means this is not exact root, this is approximate root. Now, P3.0, this much error you have. Therefore, this gives the error in satisfying the given equation. See, means suppose you substitute this value in P3 of x in the given polynomial 2x cubed minus 5x plus 1, definitely we get what's the error, how much error we get, 0.00349. Yeah, this gives the error in satisfying the given equation. The depleted polynomial after the two iterations is given by, this is b naught, means b naught x square, because we have to extract one root, means we are extracting one linear factor in a cubic polynomial. In the, you have in the problem is given cubic polynomial, we are extracting a linear, means the remaining is quadratic. This is a way I have to write the depleted polynomial. I think it's clear. Thank you very much for listening for Bridge Vita method. Bye. See you and take care.